So hi everyone, my name is Shivam Bohra. I'm a third year computer science engineering student from Dehradun. I love solving problems and I also love to teach. Welcome to our channel, Learn Competitive Programming with CodeChef. So if you are interested in competitive programming and want to learn and master data structures and algorithms, then this is a one-stop destination for you. Here we post weekly problem explanations, conceptual videos on various programming paradigms, and also conduct live problem solving sessions. So before we actually get started, here's a reminder for you to hit that subscribe button if you haven't already yet.
So in this video, we are going to solve Coprime range, which appeared in February lunchtime 2021, and the difficulty level is simple and the prerequisites are none. So the problem statement says that given a range from L to R, that is, let's say L is 3 and R is 5, so the range is from 3 to 5. So given a range from L to R, we have to print a number, let's call it X, such that this X does not have any common factors with any of these numbers. I repeat, this X does not have any common factor with any of these numbers. And I won't consider 1 as a common factor, right? So for 3, we have just a single factor other than 1, which is 3 itself. For 4, we have two factors, 2 and 4. And similarly, for 5, we have just a single factor, which is 5 itself. So now I have to choose a number x such that it doesn't have any common factor with any of these numbers. So let's say I chose 6, and for 6, I know we have three factors, which are 2, 3, and 6. But this 4 also does have a factor 2. And over here, this 6 also have a factor 2. So this 6 and this 4 does share a factor which is 2 in this case. So we cannot take 6 as x in this case. So let's try with 7. And for 7, we know that we have a single factor 7 other than 1. Right? And also, we can see that this 7 does not have any common factor with any of these numbers. Right? So simply 7 would be the answer in this case. Now there are multiple possible answers for a single input or for this case, and if there are multiple possible answers, you can print any of the possible outputs or answers. So moving on to our approach, firstly, let's say L is 2 and R is 3, right? So the factors of 2 are 2 and 1. Similarly, the factors of 3 are 3 and 1. And even the factors of, if I have had 12 as a number over here, then the factors of 12 would have been 12, 6, not 8, 4, 3, 2, and 1. These are the numbers which are the factors of 12, right? So clearly, one thing that I can observe over here is that a number cannot have a factor greater than itself, right? What I'm saying is a number cannot have a factor greater than itself. That is, this 2 over here cannot have a factor greater than 2, or this 3 over here cannot have a factor greater than this 3, and similarly this 12 over here cannot have a factor greater than this 12. Similarly, if I pick a number, let's say 4 over here, right? Then I can definitely say that all the numbers in this range cannot have 4 as a factor. I'm not talking about the factors of 4, but I'm saying that these numbers cannot have 4 as a factor. So let's call the number to be chosen as x, right? And we have, let's say we have chosen 4 over here. So what I can say is, if x, that is the number which has been chosen, is greater than this r. We know that r is the maximum value in this range. So if I have chosen a number which is even greater than this r, like 4 over here, then this means that all the numbers in this range are smaller than this 4. Since all the numbers in this range are smaller than this 4, hence they cannot have 4 as a factor, because in the previous observation we have seen that a number cannot have a factor greater than itself, right? So what I can say is, if x, that is the number to be chosen, is greater than r, then in the range from L to R we cannot have x as a factor. That is, x would not be a factor of any of the numbers in this range. But we also have to make sure that this x does not have any common factors with any of these numbers. Now, to reduce the chances of x having any common factor with any of these numbers, what I will do is I will reduce the number of factors that x has, because if x has less factors, then less would be the chances of it having any common factors with any of these numbers, right? So to reduce the number of factors of x, what I will do is I'll choose x as a prime number, because prime numbers has the least number of factors. That is, a prime number will always have two factors, which is 1 and itself. Like 5 has only two factors, which is 1 and itself. Similarly, 7 also have only two factors, which is 1 and itself. So all the prime numbers will always have only two factors, which is 1 and itself, right? 1 and itself. So till now we have made two observations. The first one is, if x is greater than r, then any number in this range cannot have x as a factor. And the second observation is, x is a prime, because this would make sure that x has the least number of prime factors, which is 2. And since x has the least number of prime factors, it would also make sure, or it would also reduce the chances of x having any common factors in this range. On combining these two conditions, we can say that since x is a prime, so it will have only two factors, which is 1 and itself, right? We won't count 1 as a common factor, so let's discard it. So we need these numbers to have x as a factor so that they can have a common factor with x, right? But also we know that when x is greater than r, then any number in this range cannot have x as a factor. So combining these two conditions, x is now invincible. That is, it is impossible for any number in this range to have a common factor with x if x is both greater than r as well as x is prime. Now, these are the constraints for L in R, and this is the constraint for x. We know that the maximum value of r could be as big as 10 to the power 6, but the maximum value of x could be 2 into 10 to the power 9. So what we can do is, we know that the maximum value of r is 10 to the power 6. So I'll find a number such that it is greater than 10 to the power 6 as well as it is also a prime. That is, I'll find an x such that it is greater than 10 to the power 6 and this x is also prime, and hence we can print this value of x for each and every test case. Because even if we change the value of L in R, our answer would still be the same. And if you want to master data structures and algorithms, or if you want to excel at competitive programming, or if you want to do really good at coding rounds as well as coding interviews, then you should consider watching the courses conducted by CodeChef itself. Now there we have many beginner level courses like Introduction to C++, Introduction to Java, and various other beginner level courses that would be taught from the very scratch. And we have very advanced level topics like dynamic programming, trees, segment trees, graphs, try, etc. Right? And you will be taught by really good educators like those who have cracked big tech companies or those who have cracked big CP competitions like ICPC, INOI, etc. etc. Right? And to watch these courses, you'll find a link in the description. And while registering, you can use my coupon code, which is White Magic 333. So moving on to the code. Firstly, in the main part, what I will do is, firstly, I'll try to find the prime factor which comes just after 10 to the power 6. That is the first prime factor which comes just after 10 to the power 6 or any number greater than 10 to the power 6, right? So I'll use a loop and I'll check if this answer is prime or not, right? So if this answer is prime, then I'll simply break this loop and I'll simply print this answer, right? And if this condition is false, then I'll simply increment the answer and I'll simply check for the next value of answer, right? And if this is prime portion, I'll simply check if this number is prime or not. That is, you'll simply check from 2 till the square root of this number and whether this number is divisible by this I or not. So if this number is divisible by I, simply return false. And if the whole loop gets executed and still you haven't found a number which divides this answer, then you can simply return true. So after running this program, what I will get is this value. This is the first prime number which comes after 10 to the power 6. So now we have this number, which is a prime number which comes just after 10 to the power 6. So what we can do is we can print it for each test case. So now what I will do is I'll simply input t, which is the number of test cases, and then for each or firstly I'll iterate throughout the test cases, and for each test case I can simply print this value, which is 10 to the power 6 plus 3. And you can also ignore this part if you want. And so this is the final code. Okay, so let's just submit the code. So as you can see over here, this is the same code, right? So let's just submit it. So we got the correct answer.